Okay, I erased your names because I'm putting this on YouTube, so you know who you are. Hello, good evening. Can't wait to see you guys tomorrow. But in the meantime, I'm going to give you a quick lesson on a few things you need to know about how you're going to tie in your project all together. First of all, the name of your project is Spinning Hydropower. But remember, when you're in a science fair or whenever you're doing a science project, you have to actually explain in some detail what it is exactly you're doing or talking about, or what forces are in play exactly. So you would want to say something like spinning hydropower, and then colon or semicolon, using water to power centripetal motion. And the reason why I added centripetal motion here is because your design, as I saw it, is moving something in a circle. So that is a very important piece to your design. So that has to be in the title. Power, that was in your original. This is the word power is right here, hydropower. Because you're using the word power, there are a few things you need to know about power dealing with physics. Number one, and I wrote it here. So force equals mass times acceleration. You don't have to really know all this yet. The beautiful thing about math is you don't have to know what things are. You just have to know how to isolate it so you can study it. Tomorrow when I see you, I'll show you what I mean about isolating a variable so that you can study it, so you can find out what it is before anybody could teach you what it is. And that's why people love math so much, because you can explore things without knowing what they are. So force is mass times acceleration. Work is force, which is mass times acceleration, which is force times distance. And you use the word work in here. You also use the word power. So power is force times distance, which is work. Power is work over time. So because your title has the word power in it, your data table and graph should be measuring parts or all parts of the formula for power. So in your data table, you need to have measured force, distance, and time. Or you should have measured work, because work is force times distance, and time. Either way, throughout your presentation, what is absent is time. And the reason why you will know that time is very important is because you've used the word power in your title, which brings you to this formula here. And because you decided to use the word power, which is nothing wrong with it at all, it's perfect. It's fantastic that you used the word power. I'm just letting you know that because you used the word power, now you have to tie it into your data. You look at the formula, you see force, distance over time, and you'll be able to understand what your data table should be measuring, or what you should be measuring. So let's look at the rest of your PowerPoint. Let's look at the abstract. I redid the abstract. It's two slides now. And there's evidence that our world's natural resources are increasingly depleting. These fossil fuels are used to power engines, facilities, and cities. Natural gases and coal are used to heat homes and generate electricity. However, water is an abundant resource that can cut through canyons and wash away cities. This force can be used to move objects a given distance in a given time. Why am I adding time? Because you use the word power, and the formula for power is work over time. You know the formula for work is force times distance, so you can say force times distance over time too if you want to. Either way, you have to add in, see, here's the word force. Force in this sentence, see the word, this force can be used to move objects at a certain distance, force times distance, that's work right there, in a given time. This makes this sentence talk about power. Does that make sense? We conducted this experiment to demonstrate how water can produce centripetal motion. Centripetal just means circle. I do not know for the life of me why don't you just say circular motion. But let's just stick to the beautiful word centripetal. Furthermore, this motion can be used to generate power. Okay. This is not perfect. I'm just trying to give you a general idea of what you should be putting in all of your sentences, putting in all of your paragraphs. I mean, not sentences, all of your paragraphs. You should be adding the word force, distance, and time. So it brings people back to the fact that you're talking about generating power. And of course, the second part of this abstract, our hypothesis states that if we use water to power our hydropower design, then we can pull objects, wait up, in, I highlighted this part, in, remember we're talking about force, a given time. The reason why you use the word given is because we don't know what the time is. We're just saying in some time, we're going to have to be able to pull objects using our design. The word pull indicates the word work. When I see this word pull, automatically I know this is work. So immediately the word pull is talking about force and force times distance. Because to pull something, you have to have a force and you have to pull it a certain distance. So this automatically gives me my force and distance. And then I added time. This makes this hypothesis talk about power. Because the force of the water will turn the pinwheel, which will turn the cork. Very good. Turn, the word turn means there's some force moving something at a distance in a circular motion. This is work right here. See how work, and then look, turn again. So you're talking about work, and because you added the word time, now you're talking about power. To test my hypothesis, I attached I have to look at this again. We don't have a conclusion yet because our data isn't put together yet. So let's go look at our purpose. How does the amount of water affect my hydropower design? How my hydropower design will work in a, remember, we're talking about power, in a given time. And we're using the word time again because the definition, the formula for power is work. Right here, see, work. Oopsie. Work over time. Work over time equals power. The formula for work is force times distance. So you can also say force times distance over time. Same thing. But now this purpose is talking about work. It's talking about power. Now, let's move on. I haven't fixed this yet, but in the background information, I was going to add in that piece. Mass acceleration is force. Force times distance is work. Power. See this right here? You can also just put the word work in here. But I wanted you to see that you can also insert this part because work equals force times distance. So you can always put that in there. And remember, we're adding the word time in to our slides because when we add in the word time, that makes this whole entire PowerPoint or slide talk about power now. If you don't add the word time, you're only talking about work. So that might make a judge who may know that ask you, in what time did you pull the object? And then you guys would be like, oh my God, we didn't measure time. Oh. Hypothesis, if we use water to power our hydropower, then we can pull objects up a given distance, up. We can pull objects up in a given time, because force will turn the pinwheel, which will turn the fork. Okay. And I might be missing things here, but I'm just quickly going through this. I'm pretty sure this is pretty thorough. So, independent variable, what's changing? you've probably changed the design of the hydropower, or what's being tested. The design, your design is being tested. But what also changes is the amount of water you're going to keep on putting in there to see how it affects the work. Now you put the dependent variable as the weight of the object. It's not. The weight of the object is actually a constant because it's not going to change all of a sudden. And you wouldn't use the word controlled variables. What is the word constant means what you keep the same. So you want to say constant variable and not control. Okay, control is the thing that's not being tested. That's a different meaning than constant variable. Constant means the thing that's just remaining the same so that you can focus on the parts of the experiment that is changing and what that change affects. So you want to keep the weight of the object the same. And how would you add on to the weight anyway? I don't think you would be able to. So weight of object is the same. So we're going to take this off. And what the dependent variable is, when you change the amount of water in, if you take some away or add some sort of amount of water into your hydropower design, what that affects is the amount of, or quantity of, or amount of work that will be done, in a given what? We're talking about power, so we have to add what word in there to make this dependent variable talk about power? In a given time. The amount of work that will be done in a given time. There are probably more constant variables. I haven't really looked at all of them, but this looks pretty solid. That's pretty good, so we'll leave it at that. And by the way, because the word work is in there, that means force is also dependent and the distance is also dependent because you have the word work in there, and the formula for work is force times distance. All right, your materials, I take your word for it. Your project looks pretty thorough. I saw it today. It looks really nice. Your procedures, as long as, let me see, you have the word repeat. Let me see. Repeat steps, awesome. And you should have the word collect data. And the word measure should be in here at some point. I'll go back and look for that. But it probably might not be in there because I looked at your data table and I'm pretty sure you was not certain what you were measuring, which is quite understandable because you have not yet reviewed that part of physics, and you won't probably go over that until you reach high school. Or you probably have some exposure to it, but not in the detail that I'm telling you. So I'm going to fix this data table, and you'll see that in this data table, because you're talking about power in your presentation, you're going to see variables. You're going to see the independent variable, which is your design, and the amount of water that you're going to be using is going to be changing. And then you're going to see force, or you're going to see the word work, and you're going to see time. And that's how that's what I'm going to put in this table. I'm going to change this, and then I'm going to go ahead and insert a graph for you. And then when I see you tomorrow, you'll be able to, and you'll see this video, you'll be able to understand why your graph looks like that and why I did it this way. And in the future, we'll go over this again when we do other projects for next semester. But it'll be easier for you to look at this video from time to time and get an understanding of how you connect your research to the science principles. In this case, you're using the principles of force, work, and power. And the motion that you'll be creating is something called centripetal motion, circular motion. Okay, that's all I have for today. Hope this helps.